Before we wind up the discussion on electron configuration, so we have to indicate some properties in the periodic table. If we have our periodic table is roughly drawn in this form, the lanthanide and the actinide series. This is F block, as we said before. This is S block. This is D block, and this is P block. So if we can locate elements in the respective block, so we can characterize the block. Elements in the S block, they are metal and very reactive. At the same time, very reactive. And elements in P block, there are some metals, and most of them are non-metal. Most of them are non-metal. If starting from group 4, 5, 6, 7, up to 8, they are non-metals, which means group 14, 15, 16, 17, 18. Group 13, since there is aluminium here, it can be a metal. So most of them are non-metals. And the P block, especially group 17, group 7 or 17, we call it halogen. The halogens are very reactive non-metal. If we see transition metal, D block, they are metals, and they are very dense, unlike the S block metals, which are very soft metals and very reactive. Unlike that one, it is less reactive. Can have a different property. It exhibits different color. And the F block, especially the lanthanide, they are very reactive metal, and they resemble each other very much. So let's take one example as a summary. Describe whether each element is highly reactive or low reactive. So I have this element, xenon, for F14, 5D9, and 6S1. Can you tell the reactivity based on the above information? And this is for A. And one example more, xenon for F6, 6S2. So I want to consider both cases so that we end up with the discussion with these two examples. So the first one, as you can see in a configuration, this has got the 5D and 6S1. So this is, it must be, the up must be the superscript. So it must be 6S1. So as it's indicated, it is the D block, because this has a pattern n-1. This is your n, this is your n, and this is your n-1. So it's a D block. So if a D block transition metal, so it has the element having xenon. If you see xenon in the periodic table tells you the atomic number of xenon. So xenon atomic number 54, this is 54, are the remaining electrons. So you end up with an element having, so xenon for F14, 5D9. So this element is found in D block, it is platinum. Platinum. If you can refer periodic table with atomic number, this platinum, if you add 54 plus 14 plus 1 plus 9, that will give you the atomic number of platinum is less reactive metal, less reactive, because it is transition metal, so less reactive. So it's less reactive, less, less reactive. If we come here, I want to understand one thing here. So far, we haven't mentioned any F configuration together with S. This is your N, and this is your N minus 2. If you end up with pattern N minus 2, F, N minus 2, F, and NS, is we call it the F block. So this is F block. Had it been transition metal, it will be N minus 1 and NS. So if it is N minus 2, it is F block lanthanide. So that is one of lanthanide series. So it is lanthanide series. So what can you say about lanthanide series? So lanthanide series. So the incomplete 4F sublevel shows that the element is in the F block and is a lanthanide. The group numbers are not assigned to the F block. The element is reactive metal. So the lanthanide series, if you can refer, it is reactive metal. Reactive metal. So in such a way you can even tell the property, chemical behavior of the elements. So it is wise to study the behavior of elements in section, in blocks, so that you can predict the behavior of elements. That's why studying periodic table is more easier, because it is highly organized. It contains highly organized information. So you can configure it, and based on that configuration, you can say something about the behavior of the elements. So